Hello and welcome to Electronic Oga. In this video, we are going to talk about two projects mixed with each other. These two projects contain the RFID module RC522 and two transmitter and receiver modules, which is for RF433MHz. Okay, this video has two sections. In section 1, we are transmitting data with Stm32 utilizing with the transmitter RF433MHz transceiver, which is an RF transceiver which modulates the signal with ASK, which means amplitude shift keying modulation, and we're sending data to ESP32. And after the tag being detected by the module, RFID module, it will be sent to the ESP32 and is received by the receiver module in there. And after that, it will blinking 1 millisecond for 1 millisecond and showing that the data is being received. Okay, this project have two sections. In section 1, we are transmitting data and reading the tag by RFID module. If the tag was correct and the access was acceptable, the data will be transmitted by the transmitter RF433MHz signal and is modulated by this transmitter and sent it to the ESP32 module. And in the other part and in other section, we are receiving this data by ESP32. Here is the data I received from the Stm32 by utilizing with this transmitter and the receiving by this receiver, RF receiver, which has 4 pins. The 2 pins in the middle is for receiving data. As here in transmitting section, the pin in the middle is for transmitting data, and these 2 pins in the middle in the receiving section is for receiving data. And 2 other pins, black and red, is for the VCC and ground. Okay. Actually, the RFID module is connected to the STM32 by the protocol SPI. This protocol SPI has MOSI, which is connected here by the yellow wire. The white wire is for MISU, the blue wire actually, and the gray wire is for SCA and SCK. Okay, and here we have the potentiometer, which is for actually for having let me show you. The middle pin is connected to the RO pin of the LCD, and the besides are connected to the VCC and ground. As you can see here, the VCC is showed by the red, and here the ground is the black pin. Okay, and actually the LCD is using the 4-bit D4, D5, D6, and D7 separately connected to the pins A, 9, 8, and other pins of the microcontroller, 4 pins, and the RS and enable pin are connected as here shown in green wires. After showing the wiring section, we're going to talk about the programming section. Programming section, which will divide it in 2 sections for transmitter and for the receiver. In the transmitter section of programming, We have two programs in order to show our data in our LCD and define the LCD pins as here constant int RS through PB12 enabled to PB13. D4 is connected to PB14. D5 is connected to PB15. D6 is connected to PA8, and D7 is connected to PA9. And after that, we have included this driver. This driver is simply added, and it's in Radiohead library for RF433 MHz. As you can see here, we include other libraries like rh_is.h, and this library is included for Radiohead library. mfrc522.h is included here, and actually is for the RFID module. NFC adapter.h is included for our MFRC 522.h, and liquid crystal.h is for our LCD is connected to the Stm32. After that, we define SS and RST pins as here for the RFID module. Define the message authorized that will be sent to the receiver as you can see here. And uh, this parameter is defined here, and we will use it in the later coming lines. And here we have MFRC 522 instance, which is needed for our module, our RFID module, and NFC adapter is included here. And in the setup, we have LCD begin, LCD clear, and after that we will print the tag reader section. And the tag readers printing, we are saying that you can have your tag connected to the module and be detected. And display begin is included, and after that rc522.pcd underlying it is included for our RFID module is also needed. After that, in the loop, we are actually searching for the RFID module, and if it's not being detected, it's going to detect the module and seeing its tag. If its tag was really true, if its tag was really true, our RFID tag, for example, is after the tag being detected and was detected in the LCD, we see that the tag UID uh, is coming to the LCD and showing by the LCD. And after that, we can see the UID of the tag. And if the UID of the tag was acceptable, the message authorized will be printed in the LCD. And if the tag was not acceptable, the access denied will be printed in the LCD. And this code is really, really simple and useful for our access control project. And I think you will enjoy it. Okay, in the receiver section programming, we have defined the RH underline AS.H, which is defined by the Radiohead library for the Radiohead library, and I defined some other includes which aren't needed here. Actually, I really intended to add the OLED device and show the data in the receiver section into the OLED device, but after that, I really want to summarize the project and not using the OLED device. You can ignore these parts. you can ignore this part. And after that, we come to the setup part, which is defined here. These lines are actually for the OLED. If you want to use the OLED device, you can have it for yourself. And uh, by the way, by the way, we defined an pin LED pin number 2, which is the internal LED for ESP32, which is in pin number 2 as an output. And in the void loop and loop section, we are going to searching for the defined for the transmitted data, and if the driver under dot receive buffer, and if the driver under receive buffer was received, we receive the data and we will locate it in the buffer. Okay, we have it in the buffer, and by delay of 50 millisecond, 50 uh, by the delaying of 500 millisecond, we are switching on and off the LED, and mm, by the our LCD, we are after blinking LED start blinking, we are success to receive data successfully, and data is being received by the ESP32, and the LED start blinking for 500 milliseconds, and after that it's going to switch off, and after sending other data for 1 millisecond, as you can see in the transmitter section. We transmit the data for 1 millisecond. After 1 millisecond, after being modulated and received by the ESP32, it's going to be blinking by the LED.